Let's take a look at a probability distribution that has a uniform distribution. So let's assume that a bus at the corner of University Boulevard Merrill Road comes every 12 minutes. And if a student arrives at the bus stop at a randomly chosen time, then the probability distribution for how long that student has to wait for the bus is going to be a uniform distribution. So let's talk about why this would be a uniform distribution. Well, if you think about it, this student is showing up at the bus stop at a random time. And so let's say the student shows up 10 minutes after the bus has already gone. That means that that student would have to wait 2 minutes. So we want to know, what is the probability that the student is going to have to wait 2 minutes? Well, the probability of having to wait 2 minutes, or let's say the student shows up 5.5 minutes after the bus has left, that means that the student now has to wait 6.5 minutes. Well, what's the probability that the student has to wait 6.5 minutes versus 2 minutes? The probability of having to wait 6.5 minutes or 2 minutes or say 1 minute or 10 minutes, right? They all occur with the same probability. They all have an equally likely chance of occurring because it just depends on what time the student shows up at the bus stop, which again, we're saying the student shows up at a random time. And so here we can see that that distribution is going to be rectangular. Now let me explain to you the drawing of this distribution. So when I take a look at the probability distribution on the x-axis here, so on the x-axis, you can see that the distribution goes from 0 to 12 minutes. So that is all the possible outcomes for waiting on a bus that shows up every 12 minutes. Now on the y-axis here, you'll see that we've got the density function, which represents the probability of having to wait anywhere between 0 and 12 minutes for the bus. Now let's talk about, so here, hopefully you will agree with me that the length of this rectangle is 12 units or 12 minutes. Now let's talk about how we determine the height of this rectangle. So what we're saying here is that every single minute between 0 to 12 minutes has the same probability of occurring. And if you take a look at my drawing here, you'll see that the probability of having to wait anywhere between 0 and 12 minutes, right, has a probability of 0.08333. So how did we calculate that value, which also represents the width of the rectangle? Well, we said that the probability corresponds with an area under the curve. So if we think about the total area under this rectangle, hopefully you can see that the entire area of the rectangle is going to have to equal to 1. The total probability is going to be 1. So let me go back to my pen here. The area of the rectangle is 1, and we know that the area of a rectangle is length times width. Then through substitution, if area is 1 and the length is 12, right? I hope you can see that we have a formula where we can solve for the width. So if I divide both sides by 12, you'll see that the width of that rectangle is 1 out of 12, which is equivalent to 0.08333. Okay, so let's take a look at some of the vocabulary words that you learned in chapters 4 and 5. So what is the random variable in this particular example? Well, the random variable here is the wait time, right? And the wait time is a continuous numerical value. Okay, and the reason why we know it's continuous is because your wait time can be a number anywhere between 0 and 12. So that includes whole minutes, half minutes, right? So for example, some possible outcomes could be you wait 0 minutes, or you wait 1.25 minutes, or you wait 5 minutes, or maybe you have to wait 9.866 minutes, etc. Okay, so what are all the possible values for x, which represents the wait time? We would say that all the possible values for x are going to range between 0, it could include 0. That means that you show up and the bus is there, okay, all the way up to 12 minutes, meaning that you show up to the bus stop and the bus literally just left, okay? All right, let's take a look at question B. Find the probability that a student, right, who shows up at the bus stop at a randomly chosen time is going to have to wait anywhere between 4 and 10 minutes. So on the graph here, I'm going to just mark in red here where 4 minutes is and where 10 minutes is. So remember that we associate probabilities with the area under the curve. So if I want to find the probability, I'm going to use the notation here. The probability that the student has to wait between 4 and 10 minutes for the bus to come, that probability is represented by the area of the rectangle that I'm shading in red here. Okay, so the area of that red shaded rectangle is the probability that the student has to wait between 4 and 10 minutes. So to find that probability, we just need to figure out what the area under that curve is. So again, remember that area is equal to length times width. So the area here, that red rectangle has a length of 6, and I got 6 because if you go from 4 to 10, that's a difference of 6 minutes. So 6, and then the width is 0.08333. So this tells us that the probability that a student has to wait anywhere between 4 and 10 minutes is going to be approximately 50%. Right, so 0.5 is the probability. So there is a 50% chance that a student is going to have to wait between 4 and 10 minutes for the bus to come. Okay, let's take a look at question C. What is the probability that the student is going to have to wait less than 4 minutes? So I will use a different color here. I will use purple, okay, to highlight a wait time that is less than 4 minutes. So less than 4 minutes would be the area of the rectangle that's shaded in purple. Right, so here we want to know what's the probability that the student has to wait less than 4 minutes. So x less than 4. And again, we associate that probability with the area under the curve. So the probability that x is less than 4 minutes is going to be the area of the purple rectangle. So again, area is length times width in this particular example because we have a uniform distribution. The length is 4 units, and then the width is 0.0833. So that gives us a probability of 0.333. So there is an approximately 33.3% chance that a student is going to have to wait less than 4 minutes for the bus.